Product and quotient rule of derivatives come very, very handy when we're looking at either product of two functions or quotient of two functions and we are trying to find the derivative. Earlier in the previous section, we saw when we had a product of two functions, we FOILed or distributed and opened up the parentheses and then applied the derivative, then used the derivative rules. But we don't have to do that. So here's the product rule of derivatives. Derivative of f of x times g of x is equal to f prime x times g of x plus f of x times g prime of x. So if f and g are differentiable functions, then their product is also differentiable. And if you're looking for product of the derivative or derivative of the product, then we would do first function times derivative of second plus second function times derivative of first. And this rule applies to more than two functions. You can have 3, 4, or 5 functions. The rule still applies. So first function stays as it is, derivative of second, plus second stays as it is, derivative of first. If we have 3 functions, first and second stay, derivative of third, plus first stay, third stays, and derivative of second, plus second and third stay, and derivative of first. So this rule can be extended to any number of functions. Let's look at some examples. So here's an example similar to the one we did earlier without using the product rule. So in that case, we ended up distributing the parentheses and for opening up the parentheses and then then found the derivative. But I'm going to be using, so this is my f function, this is my g function, and the product rule says the f derivative is going to equal, so y derivative is equal to fg prime plus gf prime. First function times derivative of second plus second function times derivative of first. When you add two terms, it doesn't matter in which order you add them, so you can switch the order. So first function as it is times derivative of 2 minus 3x, which is negative 3, plus second function as it is, 2 minus 3x stays as it is now, 2 minus 3x times derivative of first, which is 3x squared. And now I'm going to simplify. Sometimes simplification is going to take a long time, and I would just skip that foiling part. So this turns out to be negative 3x to the third plus 12 plus 6x squared minus 9x to the third. And like terms, that would be negative 12x to the third plus 6x squared plus 12. That would be it. There's no more like terms. We cannot combine any more terms over here, and that would be the end for this problem. Here's another one. So this is my first function, this is my second function. When we do g prime of x, that's going to be the first function as it is, 2x squared minus 5x times derivative of second, which will be 8x to the third minus 6x. Plus the second function remain as it is, 2x to the fourth minus 3x squared plus 2 times derivative of first, which is going to be 3x squared plus 4x minus 5. And in this case, there's a lot of foiling required. There's a lot of distributive property required if you want to open it up. I would usually not do that. But in this case, let's go ahead and open it up and see what does it turn out to be. It's going to be 8x to the 6th plus 16x to the 5th minus 40x to the 4th minus 6x to the 4th minus 12x to the 3rd plus 30x squared plus 6x to the 6th, 6x to the 6th plus 8x to the 5th minus 10x to the 4th minus 9x to the 4th minus 12x to the 3rd plus 15x squared plus 6x squared plus 8x minus 10. And I would leave up to you to combine the like terms. Combine the like terms. Normally, I would say that you can leave it in this form, and I would say do not multiply further because it's very time consuming to multiply trinomials and trinomials. All right, another example. Here we have quotient rule now. For quotient rule, if we are trying to find derivative of a quotient, means you're trying to find d dx of f of x over g of x, then it's going to be g of x squared in the denominator, g of x times f of x minus f of x times g prime of x. G of x times f prime x minus f of x times g prime x divided by g of x squared, as long as g of x is not equal to 0. So that's very, very important. The g of x should not equal to 0. So if you remember the song low d high minus high d low over low low, you will remember the quotient rule. Low d high minus high d low. Low d high minus high d low. So let's go ahead and find the derivative. Here's y given to me, and y prime would be low low x squared plus 1 squared, x squared plus 1 to the second power, low, derivative of higher term, derivative of numerator is just 5, minus higher term times derivative of lower term, which would be 2x. Cleaning up, simplification, and that would be it. So this leaves me with 5x squared plus 5 minus 10x squared, 10x squared plus 4x divided by x squared plus 1 to the second power. Okay, so at this point we can 5x to the fifth, 5x to the second power minus 10x squared. We can combine these like terms, and that's going to give me negative 5x squared, negative 5x squared. And then we have plus 4x plus 5 over x squared plus 1 to the second power. And that's our derivative using the quotient rule. That is the derivative. No more simplification is possible here, and I'm going to leave it at this point. Next, we have 2x minus 7 raised to the negative first power. So raised to the negative first power means I can rewrite it as x plus 5 over 2x minus 7. And now I can go ahead and do f prime of x, which is low d high minus high d low over low low. So lower term times derivative of higher term minus higher term times derivative of lower term divided by lower term times lower term. So this is 2x minus 7 minus 2x minus 10 over 2x minus 7 to the second power. Looks like I can get rid of the 2x and 2x here. So that's negative 17 divided by 2x minus 7 to the second power. All right. Next, we have z equals 4 minus 3x over 3x squared plus x. All right, so z prime would be low d high for lower term. Z prime is going to equal low d high, lower term, times derivative of higher term, minus, I need more space. All right, pretty big. Okay. Low d high, which is going to be z prime, 3x squared plus x times derivative of higher term, which is negative 3, times high d low. Derivative of the lower term would be 6x plus 1 divided by 3x squared plus x to the second power. And we can simplify it. At this point, we can go ahead and simplify, but I'm going to leave that fun part for you all to simplify. So I'm going to leave the fun part for you to simplify. See another example. Here we have w equals, okay, I'm going to need more space. So let's see example number 2. All right, we have, looks like I'm going to have to use product rule and the quotient rule to make my life easy. I'm going to go ahead and multiply the numerators and then go from there. So this will turn out to be 1 plus 3z times 3 minus z, which will be 3 minus z plus 9z minus 3z squared divided by 3z, which would be 3 plus 8z minus 3z squared over 3z. And now we can go ahead and either separate the 3 or we can go ahead and use the quotient rule. I think it's probably easier if I separate them instead of using the quotient rule. I can separate this into 3 different pieces and then find the derivative. So w can be written as 3 over 3z plus 8z over 3z, 8z over 3z. Oh no, I did not mean to clear the page. That was not my goal. Okay, so we have w equals, 1 plus 3z times 3 minus z over 3z. This is going to leave me with, let's go ahead and do the product on the numerator. We just did that. That's going to be 3 minus z. That was 3 plus 8z. We just found the product. 3 plus 8z minus 3z squared divided by 3z. And I can write it as 3 separate fractions. That might be easier than applying the quotient rule. So 3 over 3z plus 8z over 3z minus 3z squared over 3z. W turns out to be 1 over z plus 8 over 3 minus z, right? 1 over z plus 8 over 3 minus z. Now I can write it as w as z to the negative first power plus 8 over 3 minus z. Now when we do this w prime, it's easier than the quotient rule. Z to the power negative 1, so I'll bring negative 1 in the front and reduce the power by 1. Derivative of 8/3 is just going to be 0, and derivative of negative z is negative 1. So this is going to be the derivative in this case. Another example, h of x is 3x to the third minus x squared plus 2 over square root of x. Either separate it into 3 fractions or you can use the quotient rule, so whatever you find easier. I just showed you an example of separating into 3. If you were to separate, you would write it as 3x to the third over square root of x minus x squared over square root of x plus 2 over square root of x. And this is your h function, which is 3x to the power 3 minus half. That would be x to the power 5 halves minus x to the power 2 minus half. That would be 3 halves plus 2x to the power negative 1 half. Now we can do the h prime by finding the derivative of individual pieces. 3 times 5 over 2 x to the power 5 halves minus 1, which is going to be 3 halves minus x. 3 halves x to the power 3 half minus 1 is 1 half minus 2 times a half. X to the power negative 1 half minus 1 is negative 3 halves. And then you can simplify from there. Or if you prefer, you can go ahead and use the quotient rule. So h prime would be low squared in the denominator, lower term times derivative of higher term, low d high, 9x squared minus 2x. Not plus here, it's going to be minus 3x to the third minus x squared plus 2, and multiply with the derivative of the lower term, which is going to be 1 over x to the power 1 half. It's going to be 1 over 2 square root of x. So go ahead and distribute, simplify. Your two answers might look very different and they both will be correct. So your answers don't have to look alike depending on the technique you used. They might look different from each other and they might both still be correct. All right, next example, e to the power t over e to the power t plus t. We want to find dy dt. So I'm going to start dy dt, lower term squared, e to the power t plus t, lower terms times the derivative of higher term minus higher term times derivative of lower term. And simplification, and that would be it. So e to the power t times e to the power t is e to the power 2t plus t e to the power t minus e to the power 2t minus e to the power t over e to the power t plus 1 squared. Same term in the numerator, positive and negative, that's gone. So t e to the power t minus e to the power t divided by e to the power t plus 1 squared. And that's it. That is the derivative in this case. That's a derivative of the function. Okay, now next example. Looks like I won't be able to write it as two fractions, so my only option here is the quotient rule, or I can rationalize and do some crazy things before I do the derivative. I'm going to go ahead and if I rationalize, does that make things any nicer? I'm going to give it a try and see what happens. That would be x minus 1 in the numerator, a squared minus b squared, and the numerator would be x minus 2 root x plus 1. Okay, didn't really make it a whole lot easier, but I'm going to go ahead and use the quotient rule now. We could use the quotient rule the way it was earlier written. I can start by going low in the denominator. Lower term times derivative of the higher term. Derivative of higher term is 1 minus 2 times half square root of x minus x minus 2 root of x plus 1 times derivative of the lower term, which is 1. And that's going to be a little complex fraction in the numerator. So x minus 1 times 1 minus 1 over root x minus x. I'm going to distribute the negative there now. Minus x plus 2 root x minus 1 over x minus 1 to the second power. Okay, distribute x minus 1 inside. So x minus 1 minus x minus 1 over square root of x. It actually made it messier. Didn't make it any nicer like I thought it would make it nicer. It did not make it nicer. Let me go ahead and just complete it the way it is now. X plus 2 root x minus 1, x minus 1 squared. I'm going to get a common denominator in the numerator, which is going to be, let me add another page. So common denominator in the numerator, it's going to be square root of x, which will be x minus 1 times square root of x minus x minus 1 times square root of x minus x minus 1 minus x root x plus 2x minus root x. It's getting messy. I think it's probably easier to just go ahead and do the derivative. I'll make a separate video of doing it after rationalizing. So f prime of x would be lower term squared, lower term times derivative of the higher term. Derivative of the higher term is square root of low d high. Derivative of the higher term is square root of x, which is going to be 1 over 2 root x minus higher term, which is square root of x plus 1 times derivative of the lower term is 1 over 2 root x. Okay, I think this is easier to simplify than rationalizing. So I have square root of x plus 1 over 2 root x minus square root of x, lower term. This is going to be minus here. This was a minus square root of x minus 1. This is not in the square root. Okay, square root of x minus 1 over 2 root x over square root of x plus 1, everything squared. Okay, so 2 root x is the common denominator for the numerator. Square root of x plus 1 minus square root of x plus 1 over square root of x plus 1 squared. All right, so square root of x and square root of x cancels here, so I'm left with 2 over 2 root x over square root of x plus 1 squared. We can get rid of the 2 and 2 from there. 1 over square root of x times square root of x plus 1 squared. That's my derivative for this function. And it was easier to go with the given form than to rationalize. That would work out fine as well. You could rationalize and then do the derivative, but that was taking longer and it was more steps than this one. Okay, another example. Find the tangent line to the graph of 3x squared plus x minus 2 over 4x to the third plus 1 at x equals 1. These are actually easier and nicer because you don't have to do simplification. You know you're looking for the derivative at point x equals 1. You can just plug the point x equals 1. Let's go ahead and start with the quotient rule. Because we need the tangent line here, so to find the tangent line we need slope of tangent line. And we need the point on the line. So we need two things, slope of tangent line and the point on the line. If you know these two things, we can use the point slope form, which is y minus y1 equals mx minus x1. F prime of x is equal to 4x to the third plus 1 to the second power. Low derivative of higher term, which is 6x plus 1 minus 3x squared plus x minus 2 times derivative of lower term, which is 12x squared. Okay, now I don't need to bother to simplify at all, because I can just go ahead and plug the point x equals 1 in here. That's going to make my life easier if I can just go ahead and plug the point x equals 1 in here. If I plug x equals 1 in here, this turns out to be 4 plus 1 times 6 plus 1 minus 3 plus 1 minus 2 times 12 over 4 plus 1 squared. And that is going to be, once we simplify, this is going to leave us with 35 minus 24 over 25. 35 minus 24 over 4 plus 1 is 5 squared is 25. So 35 minus 24 is 11 over 25. That's going to be my slope. 5 times 7 is 35. And 3 plus 1 is 4 minus 2. 12 times 2 is 24. Right. So now we can write y minus y1. And the point on the line, since I know that x is 1, when x is 1, y would be equal to 3 plus 1 minus 2 over 4 plus 1. And that's going to be 4 minus 2 is 2. 2/5. 2/5. Okay. Now we are ready to write equation of tangent line. Y minus y1. Y1 is y minus y1. We just found the y1 is 2/5 times the slope x minus x1. x1 is 1. And this is the point slope form. If you're being asked to write the slope intercept form, go ahead and isolate the y by itself, and that would be the slope intercept form of the equation of line. That's the last example for this video. We talked about the quotient rule and the product rule.